All right, let's take a look at this problem where we have what is a fraction, but there's lots of square roots going on. We're going to do something called rationalizing the denominator, and this also involves simplifying radicals. So all kinds of vocabulary that's going on that makes this seem kind of complicated. And one thing that makes it complicated is there's at least two good ways to do this. I'm going to show you the one that I probably use the most, but it doesn't mean it's better than the other method. But when I see a radical in the denominator, first of all, I know that it's not simplified completely. If it's simplified completely, there's not going to be a square root, that little symbol in the bottom of the fraction. So I know that I need to get rid of that somehow. So rationalizing the denominator is a very fancy way of saying get rid of that square root in the bottom of the fraction. So I'm going to start by just multiplying the top and the bottom by the square root of 20. Now, that's not just because I just picked it, it is because that is the denominator that I'm trying to get rid of, right? I'm trying to get rid of that square root. So I'm going to multiply the top and the bottom by that. Now, this part looks a little confusing because usually we're going to see it written with the number in front if we're doing distributive property. And that's what we're doing here. We're multiplying the square root of 20 times all of this, the whole thing. So I'll write it this way just because we're used to seeing it like this. So square root of 20 times square root of 3 is the square root of 60. And the square root of 20 times the square root of 5 is, let me move myself over, square root of 100. Okay. And then on the bottom, we have square root of 20 times square root of 20, which is the square root of 400. Or you may already recognize that that is just 20, right? Because if you multiply the same number times itself and under a square root, you get that number. But we can now look at each of these parts and pieces. So square root of 60. Remember that when we simplify square roots, we're just looking to break this apart. That's the method that I use for simplifying square roots. I just want to think, what can I multiply to get 60? My first thought is 6 times 10, and then continue breaking those numbers down into smaller and smaller factors. So 6 could be 2 times 3, 10 could be 2 times 5. And none of those numbers will break apart any farther. They're called, or further, they're called prime numbers. So I'm looking at these and I know that we're doing square roots. So I'm looking for pairs of the same number. I see a pair of 2s. That means that I have a perfect square of 4 here. Square root of 4 is 2. So I know that I have a 2 on the outside, and then I have a 3 left over and a 5 left over underneath this square root. 3 times 5 is 15. So the square root of 60 simplifies to 2 times the square root of 15. All right. Now we're almost done because the square root of 100 is 10, right? Think about 10 times 10 is 100. So that's nice. That's a pair. A pair is a perfect square. So 10, and then the square root of 400, remember, is 20. 20 times 20 is 400. And so we're essentially done, but we can simplify these numbers a little bit more because they're all even numbers. When I say all, I mean the coefficient 2, the 10, and the 20, right? Those will all divide by 2. So 2 divided by 2 is 1 times the square root of 15, which is just the square root of 15. 10 divided by 2 is 5, and 20 divided by 2 is 10. So this would be our simplified answer. And if you had 5 plus the square root of 15 over 10, that would be okay too. Yeah, the order there doesn't matter so much. Okay, so that's the way I would do it. There are other ways to do it as well, but that's the way that I would go about it. All right, I hope that helps. I'll see you next time.